First of all, let's solve the following exercise. We have this binary word of length 3, and we want to change it to this binary word. So we have the binary word 001, and we want to change it to 000. How can we do that? Let's take our binary word. So we have 0, 0, 1, and we are going to change this one in the following way. First, we are going to use our first rule that says that we can always flip the first binary. So we can change this one, and we can put 1 and then 0 and 1. Now let's use our second rule. Our second rule says that we can flip any bit after the leftmost 1. In this case, the leftmost 1 is going to be this one. Yes, it means that I can change this one, and I'm going to do that. Look, I'm going to change this word into this. So we have 1, 1, 1. We have this, and I need this one to be 0. To do that, we can apply again the first rule and change this, and then we have this. We change it, and this is going to be 0, 1, 1. Now let's apply the second rule again, and we can see that the leftmost one is going to be this one. So it means that I can change this one in here. So I'm going to change it. So it's going to be 0, 1, 0. And again, let's change this one, this bit, let's change it using our first rule. So it's going to be 1, 1, 0. Now using the second rule, we can change this one. So this is going to be 1, 0, 0. And the last step is going to be use rule number 1, because we can always change the first bit. So we change this one by 0, and we obtain 0, 0, 0. And that's it. Look, we have 0, 0 coming from 0, 0, 1 using only these two rules. Now let's prove the following exercise. We are going to prove this exercise using the strong induction principle. Let me call the strong induction principle as SIP. As you already know, when we try to solve an exercise using the strong induction principle, we need to start the base step, and then we are going to start the inductive step. For the base step, it's very simple, because for the base step we are going to have a binary word of length n equals 1. In that case, we only have two binary words. For length n equals 1, we have the binary word 0, and we have the binary word 1. And using our first rule, we know that we can always flip the first bit. Since we have 0 in here, we can flip this bit into 1. And since we have 1 in here, we can flip this bit into 0. It works. We can see that our base step works. Now let's study the inductive step. Let's remember that we are proving this using the strong induction principle. That's why we are going to assume that the statement is true for any word of length k belonging to 1 till n minus 1. We are assuming that this works for any binary word of length 1, 2, 3 till n minus 1. We're assuming that. And we are going to use that assumption in order to prove that we can create any word that we want of length n from any word of length n. Okay? Let's do that. For the first case, we are going to have this. This represents the spot of the bit in the binary word. So this is going to be the first spot, then we have the second one, then we have the third one, and so on. And we have this is going to be the n-1, and this is going to be n. Okay? Now, we are assuming that this works. We are assuming that this was for n-1. If this were for n-1, we can change this word in any word we want. Since our goal is to change this bit, the last one, the bit in the position number n, we are going to change this n-1 word in the following one. We are going to put it like this: 0, 0, and 0 in here, and then 1. Why? Because now we want to use our second rule, that we can change any bit after the leftmost one. So if we have 0, 0, 0, and then 1, we can change this bit, because this one in here is going to be the leftmost bit. We can put here the desired one. So if we want the 0, we can put it, or if we want 1, we can put it. Now, since we have this, we already have this this bit, the number in the spot number n, is the one that we want. Now we need to change the bit in the spot n-1. And that's why we are using the strong induction principle. Because now, look what we have. We have this, we have again our spots. This is going to be n, this is going to be n-1, and we have here n-2 bits. And the bit that we want to change is this one in here. Since we are using the SIP, we know that this is true. We are assuming that this is true for this binary word of length n-2. So we can change this again to 0, 0. Let's put a 0 in here, and then 1. Again, applying our rule number 2, we can change this bit or 1, or either 1 or 2, or 0, sorry. And then we can go. We can go, until we reach this. That the last one that we want to change is this bit in here. But we know that by our first rule, we can change always the first bit. We can put in here any word. We can put in here any bit, 0 or 1. So the desired one. Yeah, we have proved this using the strong induction principle.